This is problem 2.1.4. We want to draw two cards with replacement. That's with replacement. X will be our number of hearts, and we want to construct the PMF, we want to find the CDF, and also say what is the most likely value of X. So for A, find the PMF, probability mass function. So to do this, we'd come up with some kind of table for here's X, here's the probability of X. Okay. So what are possible values? If we draw two cards, you can get 0 hearts, 1 heart, or 2 hearts. So let's figure out all these probabilities. If you think about a deck of cards, there are 13 hearts out of 52 total. And that means that there are 39 not hearts. So let's think about it this way. So to get 0 hearts, what do you have to do? That means you have to actually get a not heart and another not heart. So to get the first not heart, there are 39 not hearts. Now you need another heart. Now this one is with replacement, so it'll still be 39 out of 52. This gives me 0.5625. So 0.5625. So you might start trying to do this problem. You might think, I should be able to find the probability of 0 or 1 just kind of right off the bat without doing the work. But that's not true. You actually have to do a little bit of work to find these probabilities. So let's say now we want to get 1 heart. Okay, well, how do you get 1 heart? Okay, to get 1 heart, you either need to have the first one be a heart and the second one be not hearts, or you could put a union here. You need to get a not heart and a heart, right? There's 2 different ways you can get 1 heart. So if you want to get a heart first, that's 13 out of 52. And if you want a not heart, that's 39 out of 52. Again, this is with replacement, so our probabilities aren't changing. For the or, we'll do a plus. Now for not heart, there's again 39 out of them, and a heart is 13 out of 52. This gives me 0.3750. Okay, again, notice here there's 2 different ways you can get 1 heart. You need to find the probability of each of them. And finally, for 2 hearts, the only way you can get 2 hearts is you have to have a heart and a heart. So the first heart will be 13 out of 52. The next heart again will be 13 out of 52, which gives me 0.0625. So now that we found all of these probabilities, we can put them in our PMF. So our book uses the notation xi and pi for each x value in each probability. So again, we can get 0 hearts, 1 heart, or 2 hearts. So the probability of 0 hearts we found is 0.5625. 1 heart is 0.375, and 2 hearts is 0.0625. So that is your PMF. If it's a discrete function with just a few values, 0, 1, 2, we call it a PMF. Okay, now for part B, find the CDF, the cumulative distribution function. So the way we do this is, again, you'll put each x value, 0, 1, 2. And then you want to find the CDF value, okay, which we call capital F of xi. But really, what does that mean? For 0, that means the probability that x is less than or equal to 0. Okay, well, let's find that out. To get x less than or equal to 0, the only choice is 0, so that's 0.5625. Okay. For the 1, that means the probability that x is less than or equal to 1. So what values up here are less than or equal to 1? There's this one. Well, x is 0 or 1, so our probabilities are 0.5625 and 0.375. So let's add those together. And we get 0.9375. Now for the 2, that means the probability that x is less than or equal to 2. So that means we can include the 2, we can include the 1, we can include the 0. So all of those probabilities together, and they have to add up to 1. Your last value should always be 1, because all probabilities have to add up to 1 in the end. So there's your CDF. And for C, the most likely value, look at the individual probabilities. Which one has the highest probability? Probability that x equals 0 of 0.5625 is the highest probability. So you are most likely to get 0 hearts. Now you need to do the exact same thing, but without replacement.